In this video series, we're going to talk about operations on polynomials, variables, and exponents. So these are some of the more procedural ideas that sort of help us think algebraically and to be able to sort of manipulate algebraic symbols. But we won't do a whole lot of that because computers can do quite a bit of this for us. So let's just look at, first of all, this important idea of like terms. And like terms are one of those concepts that you might have faced before, you might have seen, and maybe you memorized a bunch of rules, and those rules kind of maybe sometimes stick with you, but for the most part you're just trying to rely on memory. So our goal is to understand like terms from sort of a conceptual perspective so that you never really have to truly memorize anything. Like terms are terms in an expression that can be combined to form one term. So let me give you an example. So an expression is basically something without an equal sign. So like let's say, how about 2x plus 10x? Okay, so this is an expression, and this expression contains two terms. So this is an expression with two terms. And one of those terms is 2x and the other one is 10x. Okay, well, what do we mean by 2x and 10x? Well, what we really mean here is 2 times x, and what we really mean here is 10 times x, right? So we've just learned to combine the variables and these things that we call coefficients. We've just learned to combine them without the multiplication sign. Okay, so what does this mean? Because a lot of students at this point would say, I think this is going to be 12x squared, because the exponents are both 1 and I have 2 here and I have 10 here, so I must have 12x squared. Well, this is kind of where students get lost because of the fact that they've memorized rules, and it becomes kind of hard to distinguish when to use what. Okay, so let's think about this. So I have, multiplication means copies, right? If I multiply something, if I have two multiples of, let's say, bread, then what I'm really saying is that I have 2 times one loaf of bread, right? So 2 times one loaf of bread. Okay, well in this case our bread is sort of the x, and we're saying we have 2 of these, and then over here we have 10 more of these. So we have 2 copies of x here, and then we have 10 more copies of x over here. Well, in total we actually have 12 copies of x, right? So we have 12 multiples of that, and all it takes is to recognize that x is the same object here and over here. So how would this change? Well, let's say we had 2x squared plus 10x. And our question was, could we call, so over here these by the way are called like terms since they can be combined to form one. Alternatively here, if you take a look at these two, well here I'm saying I have 2 copies of an x squared, and over here I have 10 copies of x. Well, these are different, right? Because here I'm saying I have 2 copies of x squared, here I'm saying I have 10 copies of just x. Well, if I really want to put the exponent there and say I have 2 copies of x squareds, but I have 10 copies of x's, and the reality is these can't be combined, because if I combine them, and for example, let's just say I again use this sort of mentality, I have 12x to the third power because I've decided to add the exponents here. Well, in this case, I'm saying that I started with 2x squareds and 10 x's, and now I've ended up with this new product. So if this is 2 loaves of bread and this is 10 apples, then I can't really call them 12 apple breads or 12 bread apples. That doesn't really make sense. So these things are the unique elements or the unique components, and this is telling me how many of those unique elements or unique components I have. So let's just do kind of a couple more here. So the most obvious case of an expression is there's an expression, and these are all like terms because they are just single quantities, and here I have 12 of them. But similarly, I could attach that to 3x plus 5x plus 4x. So I have 3 copies of x, then I have 5 more copies of x, and then I have 4 more copies of x. So that means I have a total of 3 plus 5 plus 4, I have 12 copies of x. Alright, now this works the same way with any exponent. So I could have 12x squared plus 10x minus 3x squared plus 12x to the third. Okay, so it looks kind of intimidating and kind of procedural. Doesn't look all that exciting, but really all I have to ask myself is, okay, well I have 12 copies of x squared over here, right? These pertains to x squared. So I have 12 copies of those, and do I have any more copies of x squareds? Well, here I have I have negative 3 copies of x squared. What does that mean? Well, it means essentially that I started with 12 and I reduce 3 copies. I give away 3 copies of that. Well, if I have 12 copies of x squared and I give away 3 copies of x squared, that means that I now only have 9 copies of x squared. Now, I started with 10 copies of x, and maybe I'll put something else around this, and I notice that there are no other copies of x in this pile, so I have to just write that down singly and say, well, I still have just 10 copies of x even once I've tried to search for like terms. So far, these two rectangles are like terms. Okay, well, here I have 12x to the third, and that's obviously the only x to the third in this, so my whole expression simplifies down to I have 9 copies of x squared, plus I have 10 copies of x, plus I have 12 copies of x cubed. All right, well, how do you justify this if this is negative? So let's say we have negative x to the third minus 20x squared plus 3x to the third plus 10x. Okay, well, again, we tackle this the same way. And by the way, if we don't put the coefficient in front, it really is 1 is just sort of a placeholder. So if I have negative x cubed, that means I really have negative 1 copy of x cubed. So how do we reason through this? Well, first of all, I'm gonna say that I'm in debt 1 copy of x to the third. Well, then somebody over here gives me 3 copies of x cubed. So if I owe 1 and now somebody's given me 3, that means that I can repay the one that I owe and that I have 2 left for myself. So in other words, negative 1 plus 3 is positive 2. Now similarly, here I have negative 20 copies of x squared, and here I have, let me add a squared here. So here I have negative 20 copies of x squared. I owe 20 copies, and somebody gives me 10 copies of x squared. So where am I now? Do I owe or do I have a surplus? Well, I owed 20. I was able to repay 10 of those because somebody gave me 10. That means I still owe 10x squared. So in other words, I have negative 20 plus 10, which is negative 10x squared. And so combining like terms is sort of just getting ourselves to think about that way. And you've probably seen these really complicated ones where they have like the 12x to the third y squared plus 2x squared y to the third. And the question is, can you combine the like terms? Well, number one, these aren't extremely realistic. You know, they maybe come up later in math whenever you're doing more complicated stuff. But realistically, we just have to ask ourselves the same question. Here I have 12 copies of x third y squareds. But over here I have 2 copies of x squared y thirds. Now, if we study the distinction here, we notice that the thing that I'm comparing, that I have 12 of over here, is not the same thing that I have 2 of over here, right? Here I have 2 x3s y2s. I really shouldn't say it that way. I have 12 x cubed y squareds. Over here I have 2x squared y cubed. So they're not the same thing, right? If these two things aren't the same, then I can't just say that I have 14. Well, 14 of what? I don't have 14x cubed y squares, and I certainly don't have 14x squared y cubed. So anyway, if you really think about it that way and forget about the rules, combining like terms is really just a conceptual little activity. Let's take a look at an example. So this is kind of a lengthy one, but we're going to really split this thing up. So let's say you are planning a trip with friends and are going to rent a van. The van you want rents for $75 per day. You are given 1,000 free miles. Oh, no, I'm sorry, that's okay. 100 free miles each day and are charged 20 cents per mile for extra miles. The dealer claims that you can expect to pay an average of $2.50 per gallon for gas on your trip. Okay, so this is covering gas. This over here is covering mileage. And suppose you are planning to be gone for 8 days and you know that you will be traveling at least 1,000 miles on the trip. You've been assigned the job of estimating the total cost of operating the van for the trip. Okay, so what we're going to do is we're going to kind of get at this. This isn't really a question, but our question is, well, how much will this cost us? Or how do we determine what this will cost us? Well, let's start with how much it costs to actually rent the van. Okay, so to rent the van, well, let's see how we would figure that out. Rent the van. And here what I'm going to do is I'm going to say that because renting the van really depends on how many miles you drive. You already know that you're going to be gone for 8 days, right? So this $75 per day charge, we already know how much we're going to be paying just to keep the van rented. But really what this depends on is the number of miles that we drive, because our cost is going to go up because of us driving more miles. Not because of driving more days, because that is explained to us that that's already been taken into account. Okay, but we're going to call this rent, or the total rent, as a function of the number of miles. So the rent will depend on the miles. So let's just say we know we're going to drive at least 1,000 miles. So I don't even want to consider anything less than that. Okay, so if I drive 1,000 miles, how much is that going to cost me to rent the van? Well, it's going to cost me $75 per day times the number of days that I have the van for. So that's going to be my rental fee in order to rent it. Okay, now to do this, well, I get 100 free miles each day, and I'm charged 20 cents per mile for extra miles. Now we know that we get 100 free miles each day, so that must mean that over the course of 8 days I have 800 free miles, right? Because nobody's going to actually be able to measure how many miles we drove in any given day. They're just going to say, well, you have 800 miles allocated to you with the fee that you're paying. So anything that you go above and beyond 800 miles, you're going to be paying 20 cents per mile. Okay, well in this case, since I've driven 1,000 miles, well that's 200 more than are allowed under the 100 free miles each day. So that means I'm going to have to pay 20 cents. I have to pay 20 cents for 200 of those miles. Well, how did I get 200? Well, that's the 1,000 that I drove minus the 800 that were free. So that means I must pay for 200 miles. Well, is that it? I think that is. I think that's basically everything that we need to account for. So in total, let's see what this comes out to. This comes out to 75 times 8 plus 0.2 times 200. Okay, so that means that total day is going to cost me $640. Well, just so that we kind of get a pattern for this, in other words, our question is going to be, well, how do we determine this if the number of minutes is just, so we don't have to keep writing line after line after line. But let's just practice one more. So 2,000 miles, well, what's that going to cost me? Well, it's going to cost me the $75 per day for each of the 8 days. Plus, it's going to cost me 20 cents for each of the miles that I drove over the 800. So I drove a total of 2,000 miles. I got 800 miles free, so that means I still have to pay 20 cents per mile for each of those extra 1,200 miles that I drove. So basically, I'm going to just pull up my last entry here. I did that by pressing second enter, by the way. And I'm going to put in 1,200 in place. Okay, well that means that my total cost is going to be $840. Well, what's the pattern here? Is there a pattern that's taking place? Well, the 75 times 8 I'm going to pay regardless of how many miles I actually end up driving. So 75 times 8 means that I've got a flat fee of $600. So this is kind of the general way of writing it. So for M miles. Okay, well what did I do? So I added 20 cents for each additional mile beyond the 800. Well, the 800, I'm subtracting the number of, I'm taking my miles that I drove minus the number of free miles. Well, if I drive M miles, that means I'm going to have to subtract away the 800 free miles that I got, and the difference there will tell me how many I need to pay for, right? That's the same thing we did here, except the number that you drove was this number, and the number that you drove here was this number, and the number that you drove here was this number. So all we're doing is just symbolically replacing things. So that must mean that to get my rental van, my rent as a function of the number of miles, it's the $600 flat fee plus 20 cents for each additional mile beyond 800. So M minus 800. In the next video, we'll take a look at the other cost, which is, what about gas, right? Because we have to pay for gas too. And so our next function will be the number, or the cost for gas as a function of the number of miles we've driven. And then we'll actually talk about why using polynomials here and combining like terms will actually prove to be a little bit helpful when we're dealing with total cost. So see you in the next video.